Before we start our tutorial video today, if you love our videos, please click on like button, and make sure to click on subscribe and bell icon, to receive notifications for future helpful content of automation and control. Now let's get started. Pressure and differential pressure transmitter applications. Differential pressure. Differential pressure is the difference in magnitude between some pressure value and a reference pressure. In a sense, absolute pressure can also be considered a differential pressure, with full vacuum or zero absolute as the reference pressure. Gauge pressure too can be considered a differential pressure, since in gauge pressure the atmospheric pressure is the reference pressure. Flow. A common application of a differential pressure transmitter is for sensing flow rate. A primary flow element has an internal restriction. This restriction reduces the cross-sectional area of the pipe through which the process flows. This restriction causes fluid velocity to increase as it passes by the restriction. Therefore, fluid immediately upstream from the restriction has a lower kinetic energy, speed, than the fluid immediately downstream from the restriction. This increase in kinetic energy across the restriction is balanced by a corresponding decrease in potential energy, static pressure. Taps placed on either side of the restriction sees a differential in static pressure produced as a result of this decrease in potential energy of the fluid. The differential pressure transmitter subtracts the downstream or lesser pressure from the upstream pressure. This pressure difference is generally quite low, typically from 1-inch water column to 750 water column, 0.24 to 186 kilopascals, depending on the fluid and flow rate. Liquid level. Liquid level measurements can be made using a differential pressure type transmitter or gauge pressure type transmitter. Typically, this is determined based upon whether the tank is open to the atmosphere or whether it is closed. Liquid level, open tank. Open tank liquid level measurement means that the tank is open to the atmosphere. In open tank applications, any change in atmospheric pressure affects the process fluid pressure within the tank. In this type of level measurement application, the low side of the transmitter measures atmospheric pressure, thus cancelling out the effects of atmospheric pressure on the tank fluid level. The high side of the transmitter is connected to the tank and thus measures the actual level of fluid in the tank. Liquid level, closed tank. From the atmosphere. As process fluid fills or is emptied from the tank, the pressure inside the tank may go from positive to vacuum. This change in internal tank pressure has a direct effect on measured fluid level, unless it is compensated for. Piping the low side of a differential pressure transmitter to the top of the tank easily does this. Bubble tube measurement. Another method of liquid level measurement is by means of a bubble tube or bubble pipe. This may be applied to either an open or closed tank. A constant pressure of air or a gas compatible with the tank contents is maintained on the pipe inserted into the tank. As the level changes, the back pressure measured by the transmitter is a direct level measurement. The advantage is that only the pipe material is exposed to the process, not the transmitter. However, the process cannot be sensitive to a gas bubbling through it. Interface level measurement. Interface level measurement, measuring the liquid level of an interface between two separated liquids such as oil and water, can be made also using the differential pressure transmitter. Liquids 1 and 2 are of different densities, and as long as the total level in the tank is above the top tap, and as long as the distance h remains constant, the change in density, and hence the hydrostatic pressure, will change with interface level change. I will issue another tutorial video about how to calculate DP transmitter range that used for interface level measurement, in the close future. Density measurement. The preceding principle leads to density measurement in a tank. In this case, a homogeneous liquid of changing density in the tank will exert varying pressure on the transmitter depending on the change in density. As long as the level remains above the top tap, and as long as h is constant, the transmitter will respond to changes in density. Density is weight per unit volume, kilograms per cubic meters. If the density increases, the pressure on the lower tap increases, and so does the transmitter output. Typically, as in level measurement, a differential pressure transmitter is used because the spans are relatively low. Also, you may refer to my previous tutorial videos about how we can calculate the DP transmitter range for an open and closed tanks, as I left the link of each video in the description box below. Upcoming tutorial video will be about how we can calculate the DP transmitter range, used for an interface level measurement. Thank you so much for watching and have a nice day.